Hello everyone, thanks for joining with us. Uh, let me share my screen. Is my screen visible? Okay, great. So as you already know, what we're gonna do is we're gonna build an end-to-end voting tab. Let me show you how we're gonna do it. So we're gonna use solidity for the front end. Solidity for the smart contract. So we write the logic in solidity, and for the front end, as I'm gonna use one of the JavaScript framework, some JavaScript library which is React.js. Yeah, man. I am, and this session is mainly about integration. So how we gonna integrate the Solidity smart contract with the front end? So I'm gonna use React.js. It's not limited to React.js. It is generic for any JavaScript framework. Like if you use Next.js or AngularJS, White, it's common for everything. So in our DApp, what we do is, so initially it's the for the election there should be a contestant. The first function is about contesting in an election and start election. And once before vote, you need to know who are the contestants, so you need to have the list of contestants, and you have to end the election to get the result. For a better you, it will start with the contest. So like a lot of people contest for elections, and it's like nomination, and the start election will happen, and we can have the list of contestants who are all in the election, who are all nominated. And then if you're not voted, you can vote, and after some time the election will end, and there will be a winner. So this is the logic of a DApp, and no time to wait. Let's get our hand dirty. So initially, I believe everyone like attending this meet through your laptop or computer. Is anyone in the meet through your phone? If you're like please switch with the computer. So what I want you to do is open a remix IDE. So just go to the URL and start at remix.ethereum.org. remix.ethereum.org. So it's a online platform where you can write and deploy your smart contract in Solidity. I'm gonna create a new workspace, and in this workspace there are a lot of things already there. I'm just gonna create a new contract file. So contract is nothing but a immutable logic that sits on chain, which cannot be changed. So consider that's what a contract is. And for the extension of Solidity, which is sol, like for the Python, the file extension is .py. Similar for java. For the Solidity, it's .sol. We have our election .sol, and let's start with the skeleton of a smart contract. A smart contract have certain skeleton, which is initially it have the license identifier, which is spdx license identifier. So I just go with unlicensed, and should have the version of the Solidity contract. So which tells the compiler version which compile this particular contract. So it's, so we have another shortcut too in the remix, which is if you use pragma, there's a, so this shortcut will help you to bring out this. So you can just take out this one. So here we have to give the version. So version is, for example, I'm using 0.8.0. so if I give something like this, and it shows like, okay, there is no contract file. Let me get into that. So you can see there are like lot of versions of compiler over here. These are the different versions of the solidity compiler. So I'm used one of them, which is 0.8.0, which is right there. And we not yet even started with our smart contract. So similarly, for anyone who have worked with object oriented programming, you can familiarize with this, which is like, for all the contracts start with wrapped around a contract, which is a keyword, and which is followed by the contract name, which will be election. And let's see what is the issue. Okay, there's a different we have used 0.8.0 as a version of the solidity, and we have here 0.8.22. so we either go and select the right one, or we can do something like, I can do give this, which is which means any compiler version that is above 0.8.0, it is compatible. So it solves that one. And this is the skeleton of a smart contract. It needs a SPDX license identifier, and the compiler version, and a wrapped contract. So every logic comes under this contract. So it's similar to I consider Java, like class name. So here we have contract and contract name. So great. So let's consider what we want to do is, we want to write a logic which helps to run a election, right? So for that, initially, in order to run the election, we need the candidates, and then we also need to count how much vote they have secured. For that, there is a special data type in solidity, which is struct. So struct is not new. People from other language background also familiarize with the struct. So I can create a struct for candidate, and which have their name and then their vote count. So in this case, name is a data type of string, and then the vote count is a data type of integer, and I'll go deep into that later. So it's a string name, as well as, so it ends with a semicolon, and it's a integer, but it's a uint. Uint means it's a unsigned integer, because vote cannot be negative. So here it's a vote count. So we have declared the struct which will contain the name of the candidate and how much vote they have secured. Great. And for election, we need to manage two things: whether this election is started or not. For that, we have let's declare two another variables. So in this case, we have either seeing the election is either started or not. It's a boolean value. So boolean is another data type that is supported by solidity, which can be declared like boolean, bool, and the access specifier, and election started. Similarly, okay, great. So far we have seen that solidity support boolean data type and struct. So similarly, it also supports uint and a string. So let's start. So first function we gonna do is contest, and then we need to start the election. We need to get all the contestants. We'll get the vote for the candidate, and then end the election and get the winner. Okay, great. So let's start. So first function we're gonna do is write a function which enables contest for the election. The syntax for writing function is in solidity, start with function keyword and the name of the function. In our case it's contest, and then it carries a parameter which is a string and memory name. So I'll explain memory in a bit. And for each function, similar to object oriented approach, we have to specify the access specifier. In our case it is public, so it is accessible anywhere by anyone. And so this function can be called with the name. So we need to first check whether there is an election already going on. And you might have seen we have declared over here two variables, which is election ended and election started, but we have not specified values for them. Solidity have this special ability which it does not allow any unreferenced variable, so that it refer to it something. So in case of boolean variables, it is referred as false by default. Similarly string, it's a null string and then a empty string, and for the event it will be 0. So that's how solidity will assign the values initially. So first we have to see whether the election is started or not. By default election is here by default it is false. So once we have to trigger and make it, until we are making it true, we cannot be able to contest. If the election is already started, once the election is started, we cannot just join in the middle, so that we have to give the a condition. How we can do in solidity is using require statement. The require statement, it takes two parameters. First is the condition, which is the election started should be false. Okay, if it is not false, which means the election is started and running, what we have to give us a second parameter, election is already started. It is the error statement, the revert statement. And we need something for remembering whether the candidate exists or not. So for that we first need to store the candidate somewhere. For that we are using an array, which is a string array, because we are passing the candidate name as string. So we are using a string array which of a public specifier, and I name it as candidate names. Okay, and we also need to check whether a candidate having that particular name is not exist. Or okay, we can even skip this condition for now and go with having the struct and enter the candidate names into the struct. So how it can be done is, so in order for using the struct, so we cannot use the struct, we can use it directly, or the one way of using the struct is creating with the an array. So in order to map, so we can create a mapping So why this mapping is, the mapping is to manage the name of the candidate along with this struct, the candidate struct. So let's get on with, so let's create a mapping. So this, for a given string, it maps into the candidate struct. So it is also public, and let's name it candidates. Okay, so let's take the mapping and for the given parameter in the contest, which is name. So we gonna do is, we gonna create a instance for the struct, create an instance for the struct, and what are the variables that the struct have? Its name, which is string, and the word count. So we are only initializing it right now. We get the name from the parameter, and initially the number of vote will be 0. Okay, that's it. So we can do something more, which is like, we, in order to like limit the same name to be a contestant for like many times, we can do another mapping, so which also takes string, but this time it returns boolean. Why we are using this is, like we can, they say something like uh, contestant check, contestant check. Why we are having this mapping is, whenever the candidate contest, we can use this and then make it like flag it as true. With that, we can again do a require statement check, for which we can use this contestant check and name. So we can say like already exist. So in order to lessen the confusion, so it should be false, because initially it should be, it's false. So if it is false, great. If it is false, we can know the candidate with particular name, consider like candidate with name Thiru is not exist. We can come down and we can have create the instance, we can flag the candidate check, and also we have this string. So this is used later, I'll explain. So first we can have this string array, and then let's push the name of the candidate into this. Okay, so far what we can have, what we have is, we have the contest function. When the name is passed into this function, it first check whether the election is started or not. If it is not started, and then it also checks whether the candidate with the same name is already called this function. So if not, great, and it comes to the next logic, which is like create an instance for the candidate struct and store it in the mapping, and then it flags the candidate name, as well as pushes the candidate name into the array of candidate names, which will be used for other things like getting the list of contestants and voting and getting the winner. So let's check. So far we can go and use the remix VM. Okay, I'll go and write some name like Thiru. Okay, great. So it passes through. So you can see over here, value passed. So great. So let's quickly write the other functions too. So which is like start election. So I have something cool for start election. So start election, for that, for start election and end election, which can be triggered only by the address which deploys the contract, which is like the owner of the contract. So for that we need to do some extra work, which is nothing but first of all we need to declare an address. So address, so which is the owner, and then inside a constructor, so constructor is a special function which is called only once when the contract is deployed. Sorry, we assign the value of the owner as message.sender. In a sense, whoever deploys the contract will become the owner. Great. And we'll write the function for the start election. Again function, and the name of the function start election. It is a public function, and so as I said, we are making it in such a way that the start election function can be called only by the owner. So we write a require statement, and this require statement checks message.sender is equal to owner. If this condition is true, your if condition is your is not true, you are not an owner. Okay, great. And then if whoever called this function is the owner, if the condition passes, what it should do is it should go and start election started is equal to true. It need to do this. And then election ended should be false. That's it, need to flag these two boolean variables. Great. Does anyone have any doubts so far? You can ask right now. Okay, I believe everything fine. Okay, okay. So that's the logic for starting the election, and we can go with getting all the list of the contestants. So again, function, the name of the function is get all contestants, and so far these are known as write functions, which means it changes the state of the variable. Either it's like changing the value of the boolean variables, or like any variables, or like creating new instance of the struct, or changing the mapping. So these change these states, so that's why it's called like it's a writing functions, and it's a reading function. For in order, so we are just going to get the list of the contestant, we are not going to change any states in the blockchain. So in that case, how we specify is again first the access specifier, and then view, and then it's a view function. So the reading function is called a view function, which only just get the data, and it's a gasless functions, and it should returns something which is the array of string, and it is flagged with memory. So let me just return candidate names. So candidate names is the array which have the name of the candidates. Great. So we have written the logic to get the candidates names as well. So we have only two more functions left. One is to vote for a candidate, and these are two functions, like ending election is one function, and get the winner is another function. Let's quickly write these three as well. For voting, function vote for candidate. So we have given the candidate's name as string. So we here also we have to use string, memory, and name of the candidate. So we have used so many places the memory along with string, because uh, these are like complicated data type which stores like a higher storage other than like event or like bytes. String and arrays have a higher storage space, so that memory is used, memory under storage, call data, these keywords used along with them. So what exactly memory does is, memory allows you to change the uh, change the state of the parameter. I can change the state of the name, but if we use storage we cannot able to do it. So that's the only difference between memory and storage when it is used along with string. Okay, let's continue. And it is also a public function. So we get the name. So first thing we need to do is, we need to check whether the election is started or not. So if it should be true. If it is not true, election is not started. And then second thing we have to do is require in the contestant check the name should be there. Otherwise we cannot vote for a candidate whose name is not even there. So we have to do give the revert statement as candidate does not exist. Okay, so if the election is started, the candidate name exists, what we have to do is so in order to track whether who voted or not, let's write another mapping. So here we should be have an address which is mapped with boolean. It is flagged as public, and let's call it voted. So first once these two statements are checked, what we have to do is we have to write in another condition. If this is for voted, for particular message.sender. Message.sender is nothing but whoever calls this particular function. So they are the message.sender, and we will say like if this is true, initially it will be false. If this is true, which means a particular person is already voted, we can say like already voted. So once these all the logics are done, what we have to do is, if it is it should be false actually. Yeah, it should be false. So for that we should make it true. Voter of message.sender should be true. Okay, so which means like a particular person is voted. And then after that we need to create a instance of a mapping which is a candidates, which comes from here. Candidate which maps with string to a candidate struct. So candidate of string, which is the name, is equal to the instance of a candidate struct. So we can have the name, and then which will return the once this mapping is called, it return the candidate struct. All we have to do is, once we pass the name, now we already have the candidate struct, we can simply access the vote count with dot operator. So it all the struct used with the candidate have the access for name and vote count. So By using the name, we can simply access the word count, and we just increase it to by 1 using this assignment operator. So that's it. So we have the logic for voting as well. We need to check whether the election is started, the candidate name is exist, you are not already voted, and then we will flag you as you have voted, and then that particular candidate's vote count is increased. Let's quickly write the logic for ending the election and getting the winner. For ending the election, it is uh, as it is like starting the election. It's just you have to write a function end election, and then it's a public here also we use the same require statement, which is like owner is message dot sender. Only the owner can call this function, and if he is not the owner, what we do is you say you are not the owner. Okay, great. So we got this, and also we have to check whether the election is already ended. If the election ended is true, there is no point of again calling this function. Okay, we have done that as well. So now what we have to do is we have to just end the election, which is election ended is equal to true. That's it. So now the election is ended. In order to get the winner, it will check whether the whoever called this function is the owner, and then check whether the election is already ended. It should not be ended. If it is ended, there is like no point of again calling the function. If it is not ended, then we will end this function in the election. So let's get the winner right now. It's a public function view. It is only a view function. The winner will be determined. We just need to fetch it from there, and it is a string. So for the first most thing, what we need to check is whether the election is ended or not. So we'll check like election ended, and if it is not ended, we'll put this message election is not ended. So if the election is ended, we can check the winner, and then the winner is a string. It's a string which will be returned, but we don't know who is the winner right now. So let's start with the event, and it's like a max vote. Let's take a max vote variable. It starts with the 0, and we gonna iterate over the candidate array, and then find out who have the maximum votes. So what we gonna do for that is we gonna use a for loop for event I is equal to 0, and till I is less than candidate names, which is it is the string array holding all the candidates name dot length, and then we'll just give the iterations. So till this condition is satisfied, we will do what is like string memory. It's a dummy variable, so it's a candidate name. So candidate name is the first the iterated value from the array. So if initially it is 0, so it will fetch the 0th value from the candidate names array, and then it will be stored in the candidate name. And then event we have oats. So what we do is we do candidates, which is the mapping in which we will pass the candidate name we have here, the first or the like individual candidate name from the candidate names array. So once we pass this, it will return the struct, which is the candidate struct, which have the name and vote count. Here we will get the vote count. Great. And then so once we got the vote count, we will check whether the votes, which is the vote count of the particular candidate, is greater than the maximum vote count. If it is true, we will simply write max votes is equal to votes. So we just map the value votes to the max votes, which we declare outside the loop. And then we also put the winner is candidate name. So this loop runs again and again till it gets the candidate name, till it gets the final winner. So once it arrives, once the loop ends, it by the time the loop ends, we will get the winner. At that time it just return winner. Okay, so each value from the candidates array is taken, which have like names like Thiru, Vaidamuthu and these names, and then from these list of names it will check the vote count for the each names, and then returns the winner who have the highest vote count. That's what we are doing here. Does anyone have any doubt so far? Okay, let's continue. So the that's all the contractors. Let's deploy. Have deployed it, the initial one. I am gonna delete it. So let me deploy it again. So let's give some contestant names: Thiru, Ravi and Mani. So we have 3 contestants, and since I have deployed, I am the owner of the contract. I only can start the election, so I start the election. So once the start election is given, we can get all the contestants list, which is Thiru, Ravi and Mani. So if we try to get the winner, it says the election is not ended. And so what we are gonna do is first from the second address, I'm gonna vote for Thiru, and if I try to vote again, it will show already voted. From my second account, I vote for Mani, and from the third, I vote for Thiru again. So if the election is ended, if I click the election is end, it says you are not the owner. So from the owner, the end election is done. If it is executed through that, we can get winner, which is Thiru. So our logic is working fine. Any doubt so far? Any doubts? Okay. So far we are only working with a Remix VM. So let's actually deploy it with the Mumbai Matic testnet. For that, what we have to do is here the environment. We have to go over there and injected provider. Once we have selected this, yeah, select. This is my one of the used account. I select this and I deploy. Sign a transaction. Okay, great. So it is deployed. I believe I have clicked it twice. No need to deploy it twice. So I have here which is deployed on Mumbai testnet. So we can verify it over mumbai.polygonscan.com. So you can see here the contract creation. Great. So this is so far the smart contract. We can quickly jump over to the front end. So how we gonna do is I'm gonna create a new folder. So okay, I'll open it with VS Code. So I'm gonna create a React app, npx create React app election. So for the front end, we need to integrate two things like except even without including the ethers and everything. The first thing is we need a wallet. So for which we're gonna use Rainbow Wallet Kit. Apart from that, we also gonna use Tailwind for some styling. Okay, great. I'll go into the folder and start the application. So go over to rainbowkit.com. Here you can go over to installation. You can use either a quick start, which helps you to spin up a React app with Wagmi hooks, so the Next.js app with Wagmi hooks and a Rainbow Wallet Kit. So we're gonna do the manual setup. So first copy this and go over to the terminal and paste here. So before it's okay, it will ask for legacy peer depths. Okay, it will be installed in that. So we need to import all of these to get the Rainbow Kit wallet in our front end application. So let me show you how what we gonna build in the front end. not this one, just wait a second. Okay, this is the simple UI we gonna do. So this is for the contest, so they can give the contest, and then for voting they can start election, and in the election and give the list of the contestants, and we can have the button for the show winner. So let's do this. So I'll stop this one and come back to our application. So as I said, you need rainbow wallet kit. So you can come here and copy these, and inside the index.js paste them, and this as well. So once you are done, copy these two wrappers as well, walkme config and rainbow kit. Anything? Sure. I'll drop the repo link over here. So everything we are doing here is in the repo. You can check it out. Okay, shall we continue? Okay, so once we take these two wrappers and wrap them in the render function. So this needs to be in the core. If you use anything, like if you're using Next.js, it should be in the wherever, whichever file the application starts. Okay, so I have used the wrappers and everything. So what we're gonna do is we're gonna go to the app.js and clean it up, and just one more thing go, which is we need a little bit tailwind help. Go to tailwind css, and so you can go over here as well in the installation. So copy them, so install tailwind and initializing them. So it have a peer dependency issue, just simply use legacy peer deps, and initializing the tailwind css. Okay, so once you are done, you will have a tailwind config.js file which will be empty initially. All you have to do is copy this and paste here. Here, but you just need to specify the JSX and TSX2. That's it. Because in React mostly use JSX. So and then in the main global.css use this tailwind base. You'll have the index.css, just clear them and paste these. So I believe this is the generic approach. You can see over here as well, like tailwind css for React. If you use this, you'll have the perfect example. So the same, it looks the same. So initialization them, and the only thing which differ is the tailwind config.js. Simply I again change them, That's it. You can see the JS, JSX and TS is included over here. So it's just simply saying the files with these extensions are allowed to have the tailwind CSS classes. Okay, now let's check it with this h1 tag. I'll also remove the classes from app.css because the style will conflict a little. Let's check everything works fine. Okay, till it loads up, let's do one thing. Okay, so in the classes we have given text tree excel, font bold and underline, so everything is reflected in the front end. And we also need the connect button, which is the rainbow wallet, which we put over here in a div. Okay, it just says wrong network because in the index.js you can see we have only used Polygon and all the mainnet. I simply use Polygon Mumbai and call it over here. Now it will be fine. Still okay, you can see. So we have a wallet, we have included the styles. So the next thing we have to do is start creating the UI and then integrating with the solidity contract. The first thing we have to do is in the source create a new folder config, and inside that there will be two files which start with ABI. ABI is the application binary interface. Where we can get the ABI is from the remix. So in the fourth icon, which have the solidity icon, you have the compiler, and here you get the ABI. Click it to copy and then go over to the VS Code and paste it over here. So we need two things for the integration. First is ABI, and the another thing is smart contract address, which is displaying over here. This is the address of the smart contract using which we checked it with the polygon scan, Mumbai.polygon scan. Okay, let's start with the integration. So first we got the config, and the second file is blockchain.js. This is my approach for the integration. So blockchain, we gonna write all our integration functions over here, and then we can just call the functions from any components. So let's start. Before that we need a few functions. So we are in the election app. First we need Web3. So Web3.js, okay, again it is the legacy peer depths. Okay, so we got the web3.js for the integration, along with we need also ethers.js ethers, but I love using this particular version, which is completely stable. So I'll prefer this one, which is 5.7.2. Yeah, I believe the same thing, which is like legacy. So this happens due to the rainbow wallet kit. So React have different versions of some packages, and these other modules comes and use which uses a different versions of packages. So that's the collision between these. No issues other than that. So we are here, we only have the wallet. We need to build the other components as well as the integration functions. So let me tell you how we're gonna start. So the first things first, we will import web3. After that we need the ABI. So where we get the ABI is ABI from dot slash ABI.json, and then we import ethers. So after we got the ethers, we need to check. So we'll have a is browser variable type, which will check the type of window, which should not be undefined. Small typo, sorry. So after that, so we gonna get from, so this is to get the window. First we'll get the window, and then from there we will extract Ethereum from the window object, which is assigned to browser. So and then we check whether the Ethereum exists or not. So Ethereum exists only when you have the Ethereum wallet like MetaMask in your browser. Otherwise it will be false, it will be undefined. So if it is exist, so I'll use the is browser function dot web3 is equal to new web3 of Ethereum on is browser dot web3 new web3 is browser. So is browser is just this function from which it is used to get the window object from the browser. So this condition is to check if the Ethereum is there, and then we will get the provider from it. So that's the output for these logics. So first whether we get the window object which have the all the variables that are in the browser. You have either Ethereum, or you can also check the same thing for Solana. We will check the whether the Solana exists or not. So it's the same thing. So these are the initial condition to check whether the Ethereum exists, which means the wallet exists on the browser or not. And we will get on with the integration functions. First, let's declare the contract address, so which we can obtain from the remix over here. Copy it and then paste it here. So this is the contract address. So here also what we have to do is we have to contest start election, get all contestant, end election, get winner. So let's start it. So it's everything is same. If you write one function, then it will be familiar for you. It's the same for like any other function. So first we'll write here and export, so that I'm giving the export keyword here. Const, it's a contest, it's a asynchronous function. All the blockchain integration calls are asynchronous function, and we pass the name, variable name, as a parameter. It's a arrow function, the name of the function, and then the asynchronous, and along with the parameter name. This is the structure for the arrow functions in JavaScript. And then we need we need three things. First thing is provider, and next is signer, and then contract instance. So in order to call a blockchain function, a solidity function which is deployed, we need these three. First is provider. So how we get a provider is const provider is equal to, first we check window dot ethereum is not equal to null. So first we check the ethereum is there in the browser, and then we do ethers dot providers dot web3 provider of window.ethereum. Window.ethereum is nothing but true. So if the window.ethereum exists, we use this function, or else we use ethers dot providers dot get default provider, which is nothing but it will either check whether the wallet is already connected. We get the provider is already there, we use that. Otherwise it will call the get provider, which will enable the MetaMask pop-up to like sign for like connect the MetaMask with the particular web page in the browser. So we get the provider. So next thing is signer. So these three steps is same for all the integration functions. So we have the signer. So what we have to do is we have to call the get signer function on the provider. We have the provider, we just simply call the get signer function on the provider. So we got the signer, and we have the contract instance. So I'll simply call it a contract instance, which is ethers dot. So it's again we use ethers for that. We use ethers contract. So we pass three parameters in this contract function, which is the address, deployed address of the contract, which we have over here, and then ABI, also signer. So we get the contract instance over here. So once we got the contract instance, we can call the contract. So we just given response is equal to, it's a asynchronous call, await contract instance dot here alone we will call the solidity function. So for the contest, what is the name of the function we have given is contest alone. So we will call that along with the parameter it is required, which is name. So once we get the response, we will console log it and also return the response. Return response. So this is the like one of the syntax for integrating with the smart contract functions written in solidity from the JavaScript based frameworks. You need a provider, you need signer, you need a contract instance, and then with the contract instance you will call any function you have written using the dot operator. That's it. So we have returned the contest function. Let's write the other functions as well, which are let's write the function for start election. So you have to do is okay, this is contract instance here. Just simply copy the function, just change the name, instead of contest, start election, and then start election doesn't have any parameters, so take out the curly braces and then check out what we have given as the function name for start election here, and then call it with that, and then it doesn't have any parameters. So that's it. So contract instance, so up until contract instance is same for all the function. You only have to change the JavaScript function name as well as the function name for the function name which you are calling from your solidity contract. So that's it. So start election is done. We can quickly also use the same thing for the end election. So change the function name end election, and here as well what we given the function name for the end election. So we have completed start election and end election. In between we need a get all contestants vote. Okay, we not yet included vote. So voting, first we will write a function to get all contestants. Let's just copy paste again, like I copy this. So get all contestants, and I'll get the function name. Okay, got it. Okay, and then we need a vote for candidate. So this is similar to so we have return function, it's a get all contestant. Here using the contract instance we are calling the get all contestants and returning the response. We got end election. We need two other functions. One is vote for candidate, integrate that, and then get winner. So let's copy this. So why I am copy pasting is because it just the same thing. You only change the name of the function. Apart from that, your provider, your signer, your contract instance remains same. So you don't need to like write it again, or like you can either have one function which execute these three and then just call that function. That is another way. That is like more efficient way as well. So I call this function as vote. So I'll call the vote for candidate along with the name of the candidate, right? So I got this function as well, vote function. So we only need to write a function for get winner. getWinner doesn't have any input, it doesn't take any arguments, so I can take them out. End election, get all contestants, start election, contest. Okay, great. So we have done so far. This all required for the integration. So these function we will use from front end components. Let's start into that. So let's create a component over here, which is which will have all the other components we build. So components, and let's write a component for contest.jsx. So we need a, so it's completely in like let's just simply put contest over here and use it here, import contest, and use contest after the connect button. I'll take this out. I'll do this. We don't need them anymore. Okay, we can see over here the contest is displaying. So let's build our contest component. So first things first, we'll give some styling. It's a flags and justify center, item centers, and get some good margin top. After that I'll inside another div which have a class name of with 72, and another div. Just I'm just styling this name. Couldn't find the remix code. I'll do one thing. Once the session is over, I'll paste it in a document and share it in your group. If that works, or like I update in the GitHub itself. This is actually the same logic I've used in the GitHub repo. Okay. So let me just continue. So I'll create a, inside this I'll create another div which will have the input for the contest. So it have a width full and a minimum width of 200 pixels, and height is 10. So inside this we'll put a input, and this input have a class with this full pair, and height is also full. Its background is transparent with text blue. Okay, 700, and font sans, some stylings for the text. and placeholder is equal to name, and we have to write a on change function as well. Before that, I'll write the label. For the label, it's a name, like either it's a name for name of the contestant would be fine. Contestant. So for the label, I'll give some styling. Just like it have a full width and full height, pointer, okay. And then along with the input, we also give a button for the submission. So which is a button for contest. Let's give some styles for this. PG2 500. It is a rounded full. So these are just some styling for the button. I'll show. So margin top, a little margin top. I'll see over here how it came out. So I believe we don't need a label, we can just do with the placeholder contestant. Okay, so we have the input box and we have the name of the contestant. There is no outline, because let's give some outline. Okay, great. So first of all, once we enter the input, it should be kept track. For that, we use use state. So let's import use state. So use state from React, and let's declare which is name, set name. So initially I'll declare as empty string, and during once the on change event is triggered, it will take the event object, and it will set name as e dot target dot value. So this is the on change function, and we have a button as well. So here in the button, once the button is clicked, I want it to do something which is called the handle submit function. So we haven't written the handle submit function yet. Let's write it. Const handle submit is equal to, I'm writing a arrow function. This function is a async function. Why? Because we're gonna call the smart contract integration function here. Before that, I just put a console log to see it's submitted. And then what we're gonna do is we're gonna integrate the contest function we return in the blockchain.js. So here we have exported it so that we can easily import here. We can import, okay, contest from config blockchain. So from the blockchain.js we got the contest function. So all we have to do is const await, call the contest function. Sorry, const some variable. I'll usually call it this is equal to await const. So we have a name, which will be passed to the name, because in the function we have declared here name as a parameter. We will specify it and pass the name from the use state, which will be changed after the set name is triggered. So after calling this, I'm gonna just simply console log the rest, which will have the like whether this function call is successful or not, we can able to get from this. So let's see once it's compiled. Okay, so let's try. So I'll put some name like Tiru again. Yes, so we have successfully integrated contest function. So we can check it over here in a few minutes when once the transaction is taken off. Okay, so yeah, yes, here we can see the function went through. Yes, so we have called the function, which will reflected in the block explorer as well. So great. So we have done one step. So the contest is done. The next step is start election. So let me just copy this button itself. See how it's looking good. So after the contest, I'm gonna create a div, which is class name flex, justify center, item center, and margin top of 6. So I put the button over here, which is like a handle submit, handle election start. So from here we have not defined this function yet, so I'll define it right here. So it's again a asynchronous function. So here we gonna create the starting like start election function. So we have already declared it at start election and end election at blockchain.js function. We're gonna just call it here. Like request to start. Just this is for just console logging it to know whether this button is clicked or not. So what we do is const this is equal to await call that particular function. So this is not the smart contract function, but this in this function that smart contract function is called. So you need to differentiate between this function and the JavaScript function. Okay, so that's it. So with this the start election function is implemented. Can see how it looks. Okay, I'll do one thing. I give a something like a h1 tag which says start the election. Okay, I believe it's not required. It's self-explanatory. The start election function is there, and let's replicate all of this along with the div, which is for the end election. So I'm gonna just comment it out for some time, or like so we will do it. So once so we have the start election. So Tidu is done. Okay, I'll do like next thing is money. Okay, let's say these these two are the contestants for the elections. Okay, if that transaction gone through or not. Okay, I believe it's gone through. So what we have to do is let me try click starting the election. Let's see what happens. It says you're not the owner. So since this address is not the owner, I cannot able to start. So I have to switch to the account which is the owner, which is here. So if I try start election, now it works. So we got a start election. The next thing we have to do is it's nothing but the showing the list of the candidates. Let's do that. So let me again pull up another div, and this div have some, it's again a flex justify center and item center. I'm just trying to make everything in center. That's it. After that we put a button, so I'm gonna use this same button class, and here instead of handle election start, we have handle get contestants. Contestants. Okay, so we have not yet defined this. Let's define this. Const all contestants is equal to is an asynchronous function. All the smart contract integration functions are the asynchronous function. From here what we gonna do is we gonna like again console log just get contestant, and after that so we gonna need another function which is get all contestant from the blockchain.js, and I'm gonna call that function. It doesn't need any other parameters. Get all contestants, just console log it to see. Also I'm gonna use a use state as well. Let me use it. Import use state and declare the use state snippet here, which is contestants set contestants set contestants. Initially it should be an empty array because the contestant list is an array. So once I got the contestants, what I will do is I'll just set it to the use state, set contestant of this. That's it. So I'll got the contestants right now, so I'll simply call them over here. Okay, it's still in start elections. Okay, I'll convert into get all contestants. Okay, so we got the get all contestants button. So once it is clicked, it will show the, it will get the all the contestants list from the blockchain, but we need to show it. No, so for that we'll use another div. I'm using div to just separate these things. Here we have the I'll just separate it a little bit from the above button, and using we have the contestant use state object. From that, if that exists, if that is like defined, which is like not null, if any values in it, which is possible only if we get the contestant from on chain, we will do contestants dot map, which like loop over each contestant. So we'll loop over each contestant. So what we will do is we'll return a div with key as an index. So just to differentiate each element, along with the class name, which is just to differentiate with in the vertical way. So I give the margin in the y axis, and each one have a paragraph tag. I'll style it quickly. So have like, let's put it in the center and make it big. So first it will show the contestant. So it will testant it for the each value. So just for the numbering purpose, I'll put the index. So it will start with 0, so that I'll put +1, so that it start with 1. So this is done for the get contestants. Let's check it out right now. So the start election is already done. Let's do the get contestants. So it's okay. I'll miss the dot over here. Now it's fine. So we get two contestants. One name is Tiru, another name is Mani. Great. So next step is we need to get a function to vote. So what we're gonna do is still similar to contest, so that I'm gonna simply copy the whole contest and create a new component which is vote.jsx. Paste it here and change the component name vote. So here only few things we need to change. Some of them are just which function we get from the blockchain config. Vote, we get the vote. Initially for the contest we get the contest function. Here we get the vote function. Okay, I believe there is some, okay, it's been a issue. I'll change the vote function here as control F, vote for candidate. I just change it over here because there's a naming conflict. Okay, got it. So I'll change it over here as well. That's it, because both the contest and the vote have the similar way of getting the inputs. Just change the name of the function. Here we calling the vote for candidate function, which calls the vote function of the smart contract. So we got it. All we have to do is just go over to the app.js and import it, vote, and call the function after the candidates list. Maybe I put it inside a div, or like simply call vote. If I go over here, I can see the name of the contestants here and vote. So with 0x8d I vote for Tiru. And I'll change the address, the second one, and I vote for Mani. And so it's like if we try to vote twice, it shows you are already voted. and with the third account I again vote for Thiru. Okay, so I have Thiru got 2 votes and Mani got 1 vote so far. So great. Next what we're gonna do is we have to end the election and then get the winner. These are the just 2 functions more. Let's So the end election is nothing as simple as the start election. Copy the same component, go over after the vote, paste it and change the text. Instead of handle start, so just copy them, handle election end. So here we're gonna call end election function. So end election function which have the smart contract function of end election. We're gonna simply put this function inside the end election button on the on click, which will enable the function to end it. Let's check it out. So this is not the address of the owner. If I try to call this function, it will throw an error, you are not the owner. So that we have to go with the owner address, which is this one. And if I do it, okay, this smart contract end election function is called and executed. Can see it over here in the console log. Yeah, I still put in the request to start. It should just convert into request to end. So the end election is done. So this function is called right now. So what we have to do next is to get the winner, who is the winner from the election. So that's the last goal of our workshop. Let's quickly get into that. So I just need another div with the button, so I'm just gonna copy it down. So instead of end election, it's like get winner and handle get winner. So this function is not yet defined. Let's define this. Handle get winner. So log request for winner. So just to check whether the button is working or not. So let's before that let's get the function for get winner. So we get it from the blockchain.js and let me just call it. So get winner and console it. So similar to what we did for the candidates, contestants, we also need a use state in order to display it. So that I'm gonna use a use state which is winner, set winner. Initially it is a empty string, and once we get a winner, it will be set to the whatever we got it, and then and again I take another div just for showing the winner who it is. It's again the same old trick, flux justify center and item center, and here we gonna put if winner exists and we will show the winner, nothing more, nothing less. Okay, and then we have not yet called the winner. Get winner. Okay. Okay, that's it. So we have seen through end election. We only need to do get winner. Let's do it. Yes, the winner is still, of course. So and who have any doubts on the code, or like if you couldn't follow along, I can understand it's only 2 hours workshop. You can reach out to me. I'll leave my Twitter over here. So here's my Twitter. You can reach out to me over Twitter, and all of our TPG's groups are open. You can go to me. You can connect with me through there in the groups as well, and the code is here. And if like I believe someone asked for the contract. In the source you have the contract.sol, which have all the logics. And for those who missed, the main integration functions are written in the blockchain.js. You can refer through this. Maybe like some function names would be changed. Other than that, everything is remain unchanged. So you can refer with that. So yeah, that's all, folks. Actually, I'm recording with the like the and MacBook default recording. I'll share you through maybe like Drive link. Yeah, thank you. Yeah, thanks for having me, guys. Kudos. See you at Eat India. Yeah. See ya. Yeah, thanks for having me. Anyway. Yeah. See you guys. Bye.